Hi guys, this is the Innovative Minds Tutor. In this video, we are going to work with function. We are specifically going to look at question 4, right? Where we are given an exponential. At 4.2, we are given a hyperbola. Those are the two functions that we are going to work with, right? If you are new to this channel, what are you waiting for? 1, 2, 3. Let's subscribe. You only subscribe once. And for those of you who will be writing paper 1 this upcoming Friday, I would like to wish you well, guys. All of you, all the best. And you have worked hard since the beginning of the year. Nothing will defeat you as long as you believe in yourself, as long as you believe that you will achieve the goal. Go with a positive mindset and you will reap good results, right? So let's put this into practice. We are given that the function p of x is equals to 1 over 3 to the power of x. Is p an increasing or decreasing function? In this case, p will be a decreasing function. What causes it to be a decreasing function? Remember that the effect of a, when a is less than 0, we'll have a decreasing function. So in this case, is less than 0. So what will be our answer? Let's put that into practice. We are at 4.1.1, so it will be a decreasing function. So this question paper specifically that we are looking at, it's May-June 2023, SC and NSC, yes, that was May-June 2023, right? Let's put that into practice. 4.1.2, determine the inverse of p in a form of y is equals to. Let's write the original equation of p. Remember that it was given as y is equals to 1 over 3 to the power of x. This is what you should remember, guys. This is what I want you to take note of. No? The inverse of an exponential function, it's a logarithm. Inverse of a logarithm is an exponential. Inverse of a parabola, it's a root function. Inverse of a root function, it's a parabola. So, but in this case, inverse of exponential, it's a logarithm. First thing first, you interchange. Where there is x, you replace it by where there is x, you replace it by y, and where there is y, you replace it by x. Where there is y, you replace it by x, and where there is x, you replace it by y. So we have interchange. Then remember that log says log base, which is 1 over 3, and the number, which is x, is equals to y. Definitely you got that 2 marks because they said leave it in a form of y is equals to. So let's go to 4.1.3. Write down the domain of the inverse. 1 mark. The domain in this case will be x is greater than 0. Right? It's very important that you sketch your graph. Looking, when you sketch this graph, you will see that the domain there, it's x is greater than 0. Comma. Let's put that into practice. Domain. Remember, domain is talking about the set of x values. So in this case, it will be x is greater than 0. And x is an element of real numbers. Then we are good to go. We are good to go. Good to go. Then 4.1.4. 4.1.4. We are given that p of x minus, they want the asymptotes. So remember that the equation of p of x in this case will be 1 over, let's just say 1 over x, 1 over 3 to the power of x minus 5. So the asymptote will be this one. So other way it's y is equals to -5. This is the asymptote, a horizontal asymptote. Remember that the exponential has horizontal asymptotes. Then let's go to 4.2. At 4.2, we are given a hyperbola, right? That's, remember this is a beautiful 18 marks. Functions are nice, guys. You just have to know the basics, then you'll be fine. Write down the equation. Write down the equations of the asymptotes of f. So we got a vertical asymptote, which is x minus 1. First thing first, let's write this. We are given y is equals to 4 all over x minus 1 plus 2. So this is a vertical asymptote. It's the one that goes like this, that cuts the x's. Then we also have the one that's a horizontal asymptote. So in this case, we have x minus 1. You equate it to 0, then transpose negative 1 to the other side, becomes 1. Then take this as the way as it is, y is equals to 2. So that's how we can get that beautiful 2 marks. So let's go. Calculate the x-intercept of f, 4.2.2. All right, this one that we were dealing with was 4.2.1. Now we are dealing with 4.2.2. They want the x-intercept of f. So let's write the equation. Remember that it's y is equals to 4 all over x minus 1 plus 2. For x-intercept, you let the y be 0. Meaning that where I see y, I'm going to replace by 0. So it's going to be 4 all over x minus 1 plus 2. To make my life easier, I could just transpose 2 to the other side. That becomes negative 2. So I'm having 4 all over x minus 1 here. Negative 2 divided by 1, then we cross multiply. Negative 2 times x, that will be negative 2x. Negative 2 times, it's like this, guys. It's like this. Negative 2 times x is negative 2x. Negative 2 times negative 1, that's going to be positive 2. So 4 times 1, that's going to be 4. So we have negative 2x. Transpose 4 to the other, 2 to the other side. 4 minus 2, that will be 2. Hence, we have x as negative 1, because when you divide everything by 2, 2 goes once at 2. So that's going to be x is equals to negative 1. So this is the x-intercept, negative 1 and 0. That's the case. Then, let's see. At 4.2.3, sketch the graph, label all the intercepts, and indicate the asymptotes with the x's, right? In this case, at 4.2.3, they want us to sketch, guys. Let's put that into practice. Okay, we have the y-axis. We also have the x-axis. So we have x is equals to x minus 1, which was our asymptote was 1, the vertical one. It cuts. Let's say it cuts here. In this case, I have x is equals to 1. Then also have y is equals to 2, 0, 1, 2. Let's say it's here. This one, okay, which is y is equals to 2. They should not meet. Remember, dotted lines them. Then our x-intercept was negative 1. So 0, 1, negative 1. Maybe it's here, negative 1 and 0. Okay, we have this. So what about the y-intercept? So let's try to get the y-intercept. If where there is x, you can substitute by 0. So just say 4 all over 0 minus 1 plus 2. Our y-intercept is negative 2. So we have y-intercept is negative 2. So that will be 0, 1, 2. Have 0 and negative 2. So we could see that we have such shapes here, such shape here. Since A is greater than the other one, will be on the first quadrant. I guess there will be something like this. We'll have something like this. Yes, yeah, that's how it should be. Yes, first on the third quadrant. That's how it should be, right? Because all right. Feel free if I made mistakes, cause we can make mistakes. We are humans, but there's always a room for learning. But yeah, this is how it should be. You should include all the asymptotes. We could see the x-intercept with the x's, right? So let's go to 4.2.4. use your graph to determine the values of x for which 4 all over x minus 1 is greater than -2. Okay, let's put that into practice. So they said use the graph to determine the values of x for which 4 all over x minus 1 is greater than or -2. So we are going to use a graph. So let's refix this first. Take this -2 to the other side to get a mark for saying this greater than or equal to 0. So in this case, by the look of things, where but here it's decreasing, meaning that the x value will be x is less than -1. At the same time, it will increase at +1. So we could just say x is greater than 1. So there are two values. If you look at our sketch there, right? Okay, so these are the solutions in this case. All right. Let's go to the last question of our video, 4.2.5. Determine the equation of the axis of symmetry if there's a shift of x minus 2 that is a negative gradient. Okay, let's see when they shift this graph, what is going to happen. So we have 4.2.5. Remember, our equation was given as the original equation, 4 all over x minus 1 plus 2. But now we're told that there's a shift f at x minus 2. Meaning that where there is x, we are going to replace it by x minus 2. Minus 1 there, plus 2. Then we have -2 minus -1, that's -3. That changes the asymptotes, right? It changes our asymptotes. Then we'll have this coordinate of asymptotes 3 and 2 in this case. Because they are looking for, let me have a space here. Because they are looking for a symmetry that is, the equation of symmetry that has a negative gradient. So we're going to say, this is the formula we are going to use. Y is equals to -x plus c. So substitute this coordinate. This is x and this is y. Meaning that where there is y, you're going to put 2, and where there is x, you're going to put -3 plus c. Then take -3 to the other side. This will be 2 plus 3, which is 5. So the equation of symmetry that has a negative gradient will be -x plus 5. So that's the solution in this case. That's how, guys, we can work out question 4, right? So probably exponential and hyperbola, they will always be there, guys. We have learned in this video. Hope you find this video useful. Do not forget to comment, subscribe, and like the video, and keep sharing. And remember, we love you. See you on the next video, where we are going to look at what? We are going to look at question 5. Question 5. Then as well as we are going to look at functions. Let's go as we are preparing for our final examination. Hope you find this video useful. Do not forget to subscribe, like the video, and comment. See you. Take care and all the best. Hi, guys. I noticed from our previous video, I noticed that I made a mistake at 4.2.3 on May-June 2023. So our sketch, I drew my sketch here in our previous video, and I was supposed to draw it here. So that means the shape should be here, guys. Sorry for that silly mistake. We'll have a shape like this in this case as well. Yeah, it should be here, right? It should be here. It should be here. Sorry for that. Yeah. That's how we were supposed to sketch our graph. Remember that to put this is x equals to 1 and this is y is equals to 2. Those were our asymptotes, right? Remember, you said sketch the graph of f, label all the asymptotes and indicate the intercepts with the x's. Right? That was 4 marks, right? So hope you saw how we should sketch it, and Do not forget to like the video and subscribe. We love you.